Hello everyone, welcome to Code and Learn. In this video, we are going to look at the binary addition problem. In the problem, you have to write a program which takes two strings A and B representing two binary numbers. You have to return a new string of bits representing their addition. So basically, we need to perform binary addition of two numbers that are provided to us in strings, or the binary numbers are presented as a string and we need to return a string representing their addition. First, let us look at the binary addition, which is different to a decimal addition. In binary, one digit can only have two values, that is 0 or 1. So 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is 1. This is very similar to the decimal addition. But next, we have 1 plus 1. In decimal, you will have 2. But in binary, it is represented as 1, 0. This is not called 10, but 1, 0. Then we have 1 plus 1 plus 1, which is represented as 1, 1. These are all the additions that you need to know to solve this problem. Now let us look at an example. In this example, we have two numbers, 100 and 001. We need to perform addition and return the result. So we say 0 plus 1 is 1. There is no carry, so 0 plus 0 is 0. Then 1 plus 0 is 1. So we can simply return 101 for the addition of these two binary numbers. In the next example, we have 111 plus 101. In this example, we will have carry. So let's see how to deal with it. 1 plus 1 is equal to 10. That is, 0 goes here and 1 is carried over. So it becomes 1 plus 1 plus 0, which is 1, 0 again. 0 goes here and this 1 is carried over to the next addition. In this case, we have 1 plus 1 plus 1. So it becomes 1, 1. As such, we need to add another 1 to the front. So this is the output for this addition, that is 1, 1, 0, 0. Now let's translate this solution into the code. The function here is called binary addition. We are accepting two strings A and B and returning the sum as a string. To make things easier, we need to perform padding, that is, adding an extra set of zeros to the front so that when we perform the iteration to perform the addition, we don't run out of index. So I can say padded A and padded B are equal to A and B. That is, to start off they are equal to A and B. Then we perform a length check, that is, if length of A is greater than length of B, we need to pad B with zeros to make their length equal. So I can say padded B is equal to pad left, which is a function we will create, provide B and the length of padding to be added to the front, which is length of A minus length of B. Just need to update it to say padded B. Similarly, I can do the other case where length of B is greater than length of A. In this case, we need to update A. That is, padded A is equal to pad left A, length of B minus length of A. Now let's add the pad left function. S is a string that we accept and L is the length of padding that we need to add. We return a string in the response and we say if I is equal to 0, I less than length of the padding I plus plus, and then S is equal to add 0 to the front of the string. At the end, return S. I forgot to add a colon here. Now let's start the loop to perform the addition. Before doing that, I will initialize a result string which we will use to create the result of the addition. Then I will initialize another variable, carry, which will be used to store the carry of the addition. We will set carry is equal to 0. Let's start the loop. We start from the end, that is length padded A minus 1. Since length of both the padded string is equal, we can use any string here. I greater than equal to 0, I minus minus. Again, just to recap, we are starting from the end because we want to move from the LSB towards the MSB, or from least significant bit to the most significant bit. Inside it, I will say var sum int, which is used to store the sum. If padded A I, that is, bit at this current position is equal to 1, increment the sum by 1. Next, we do the same for B. If padded BI is equal to 1, add to sum again. Now, the final sum would be sum is equal to sum plus carry. Then we perform a check. If sum is greater than equal to 2, that is, we have a carry. Carry from this addition. So we can say carry is equal to 1, sum is equal to minus equal 2. We are reducing the sum by 2 because that is the sum of the current iteration, or the least significant bit of the current addition. Else, we don't have any carry. As such, we set carry is equal to 0. Now the result can be appended. Result is equal to string conversion, integer to a string, sum plus what we already have. So we are adding to the left of result one by one. So by the end of this loop, you will have the sum. After the sum, we need to check if there's still a carry. If there is one, that is carry is equal to 1, or you can also do carry greater than 0. Result is equal to append to the left or append the carry to the left, that is 1 plus result. In the end, return the result. So that's our solution here. To recap, first we create a padded A and padded B, assigning them the value of A and B. Then we check if the lengths of two binary representations are not equal. If that is the case, we pad the smaller one by the difference of two lengths. This is helpful when we go through this loop. Before starting the loop, we initialize a result string to store the result and then a carry to keep track of the carry for each addition. Inside it, we have sum which is initialized to 0. If the current bit in A string or binary number A is 1, we increase the sum. If the current bit in binary number B is 1, we increase the sum again. And after that, we add the carry if there's any. Now to decide if there's carry to be carried forward, we see if sum is greater than equal to 2, that means there is a carry, so we set carry to 1 and reduce the sum by 2 since we have already carried over. This sum after a reduction of 2 is the current sum of the iteration. Otherwise, we do nothing with the sum but set the carry to 0 and then we add the current sum to the left of the result. At the end of the loop, we should have the result, but we need to also count for the carry. If the carry is 1, we add it to the left of the result and in the end return the result. So that's the solution for this problem. The time complexity of this solution is O of n. Since we are not using any additional space, the space complexity of this solution is constant, which is O of 1. That's it for this solution. I hope you enjoyed it. If you have any questions, please post a comment under the video or reach out to our Discord server. Until next time, happy coding!